We all know that if you want to get ahead in life, you generally have to work hard. And you do even better when you work smartly and efficiently. If you want to understand physics, you need to master mechanics, the classical physics model of how things move, or remain stationary, or transfer mechanical energy from one thing to another. Mechanics is made up of three main topics: motion, forces, and energy. All three are linked in a way to work. Work? What is it, really? Something teenagers avoid at all costs? Something farmers and cashiers or accountants do? Well, let's look a little closer. Man, animals, and machines are busy at work every day. The receptionist answers the telephone and keeps track of bookings for venues and events. The cashier at the supermarket checks out the groceries and handles the transactions with customers. The diesel mechanic keeps the fleet of trucks in safe and good running order. Teenagers work hard when they study for exams. The guide dog helps the blind handler navigate the busy street. And these people and things are working. You can work out at the gym by lifting weights, cycling, swimming, or running on the treadmill. Motion can be further subdivided into two main topics: kinematics, the study of how an object moves, and dynamics, the study of forces and their effects on motion. This overlaps with the main topic of forces. We show the overlap on the diagram. Dynamics belongs also to the topic of forces. Statics deals with forces that keep objects stationary, for example, the trusses on a bridge, struts keeping the wings of an aeroplane in position in all weather conditions. Forces are also involved in doing work on objects, so again, we have the overlap of topics with one another. Work is related to energy. We define energy as the ability to do work. They are inseparable in many ways, and they are linked further with the work-energy theorem. Energy conservation is one of the basic principles of science. We cannot make more energy or destroy energy. Energy can be transformed from one type to another or transformed from one place to another, but it's always kept intact as energy. The final part of our concept wheel for mechanics is kinetic energy. Kinetic energy is the energy an object possesses because it is in motion. And possessing kinetic energy means that the moving object must be subject to the principles of kinematics. And so we complete the wheel. So it seems that force is one of the ways that objects transfer energy, and so they are doing work. This also means that they cause motion in many cases. So how does that actually help us with anything? Well, to show you how this helps, we're going to climb some stairs. In one case, we simply walk up the stairs to the top of this 3-meter-high staircase. We've done work because we've had to resist the gravity acting on our bodies. Now, what if you could climb a ladder to the same height? The ladder seems to be much quicker but more difficult. The weird part is that we've resisted gravity and landed at the same height above the ground. We've done the same amount of work. But why was it more difficult? How about this question to discuss with friends? You have to fill up a large tub of water on the roof. It can contain 1,000 liters of water. That's a whole ton. This is clearly too much to carry up 5 meters to the roof. How could you fill it up? Well, it turns out that if you make the same trip of 5 meters many times, you could use less force to do the same work. So understanding these principles can literally move tons of water. Learning about energy principles enables you to solve some of the other problems which you have come across in kinematics and forces in a much simpler way. So let's not waste time and energy. Let's move on to work, energy, and power.